Online Class Philippines. Hi guys, today we are going to study about factoring polynomials. Factors can be either numbers or polynomials. When an integer is written as a product of integers, each of the integers in the product is a factor of the original number. When a polynomial is written as a product of polynomials, each of the polynomials in the product is a factor of the original polynomial. When we say factoring, it is writing a polynomial as a product of polynomials. Let's talk about greatest common factor, or GCF. It is the largest quantity that is a factor of all the integers or polynomials involved. Finding the GCF of a list of integers or terms. First, prime factor the numbers. Next, identify common prime factors. Third, take the product of all common prime factors. If there are no common prime factors, GCF is automatically 1. For example, find the GCF of each list of numbers. Number 1, 12 and 8. So 12 will be 2 times 2 times 3. And 8 will be 2 times 2 times 2. So the GCF, or the common, we have the 2 and the 2 and another 2 and another 2. So that will be 2 and 2 will be 4. 7 and 20. 7 is equals to 1 times 7. Next, 20 is equals to 2 times 2 times 5. So there are no common prime factors. So the GCF is 1, 3, 6, 8, and 46. The GCF for number 6, we have the 2 and 3. 8, we have 2 times 2 times 2. 46, we have 2 times 23. So the GCF is 2. Next, in number 4, we have 144, 256, and 300. So 144 will be 2 times 2 times 2 times 3 and 3. 256 will be 2 times 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 2. And 300 would gonna be 2 times 2 times 3 times 5 times 5. So we have two sets of GCF. We have the 2 times 2, so that will be 4. Another example. Find the GCF of each list of terms, x cubed and x to the second power. We have x cubed, or x to the third power, is equal to x times x times x. X to the seventh power will be x times x times x times x times x times x times x. So we have 3x in common. So that will be x multiplied by x and another x. That will be x to the third power. Next, number 2. 6x raised to the fifth power and 4x cubed, or to the third power. 6x to the fifth power would gonna be 2 times 3. That will be for the 6th, multiplied by x times x times x times x times x. That will be for the x to the fifth power. Now, 4x cubed, or to the third power, would gonna be 2 times 2 for the 4. And multiplied by x times x times x for the x to the third power. So gonna be, there will be 2 and another x and x and x. So that will be 2 and 3x. So that will be 2x to the third power. Next, number 3. You have a raised to the third power, b to the second power, also with a to the second power, b to the fifth power, and a to the fourth power, and b to the seventh power. A third, b to the second power is equals to a times a times a times b times b. So there will be 3a and 2b. Next, a to the second power and b to the fifth power. So that would gonna be a times b times b times b times b times b. There will be 2a and 5b. A to the fourth power and b to the seventh power will be a times a times a times a times b times b times b times b times b times b times b. So there will be 4a and 7b. So what are the common? We have one a, another a, b, and another b. So that will be 2a and 2b. So that will gonna be a squared b squared. Well, that is the GCF. Factoring polynomials without or factoring out the GCF. The first step is factoring a polynomial to find the GCF of its all terms. Then we write the polynomials as a product by factoring out the GCF from all the terms. Next, the remaining factors in each term will form a polynomials. For example, let us factor out the GCF in each of the following polynomials. 6x third or cubed minus 9x squared plus 12x. So 3 times x times 2 times x squared minus 3 times x times 3 times 3 plus 3 times x times 4. So that will be 3x, open parenthesis, 2x squared minus 3x plus 4, close parenthesis. Another, factor out the GCF in each of the following polynomials. So 4 times x squared, so that y4, because that will be 4 times 4, then x squared times x squared, times 2 times 2 times x squared plus 4 times x times 2 plus 3 times x squared times x times 4. So that will gonna be 4x squared, open parenthesis, 4x squared minus 2 plus 3x, close parenthesis. Remember that factoring out the GCF from the terms of a polynomial should always be the first step in factoring a polynomials. This will usually be followed by additional steps in the process. Example, factor 90 plus 15y squared minus 18x minus 3xy squared. So that will be 90 plus 15y squared minus 18x minus 3xy squared is equal to 3 multiplied by 30 plus 5y squared minus 6x minus xy squared. So here is the answer. So it will gonna be on the end 3 multiplied by 6 plus y squared multiplied by 5 minus x. Factoring trinomials. That will be x squared plus bx plus c. Recall using the FOIL method that first you're going to multiply the first, we have the x multiplied by the x, so that will gonna be x squared. X multiplied by the last part of the second term, that will be x times 4 is equal to 4x. Followed by the other one, 2 times x is equals to 2x. 2 times 4 will gonna be 8. So if we're going to simplify it, that will be x squared plus, we're going to add the 4x plus 2x, that will be 6x plus 8. To factor x squared plus bx plus c into x plus one number multiplied by x plus another number, note that b is the sum of two numbers. In this case, we have 4 and 2. And c is the product of two numbers. So we'll be looking for two numbers whose product is c and whose sum is b. There are fewer choices for the product, so that's why we start there first. So factor the polynomials x squared plus 13x plus 30. Since our two numbers must have a product of 30, and a sum of 13, two numbers must be positive. So positive factors of 30 will be 1 and 30, 2 and 15, 3 and 10. If we're going to add the 1 and 30, that will be 31. So that is not the answer. 2 plus 15, that will be 17. So that is not the answer. 3 plus 10 is 13. So that will be the answer. Note, there are other factors, but once we find a pair that works, we do not have to continue searching. So once you already have 1, then so be it. So x squared plus 13x plus 30 is equal to x squared plus 10x plus 3x plus 30. So in this case, x multiplied by x plus 10 plus 3x plus 10. So now gonna be x plus 3 multiplied to x plus 10. So that is our factor. Another factor, the polynomial x squared minus 11x plus 24. Since our two numbers must have a product of 24 and a sum of negative 11, the two numbers must both be negative. So we have negative factors of 24, negative 1 and negative 24. If we're going to add, that will be negative 25. So that is not the answer. Let's try another one. Negative 2 and negative 12. If we're going to add, that will be 14, and that is not possible. If we're going to do the negative 3 and negative 8, then that will be negative 11. So x squared minus 11x plus 24 is equal to x squared minus 8x minus 3x plus 24. So the answer would be x minus 3 multiplied by x minus 8. To check if your answer is correct, go again to the FOIL method. Factor the polynomial x squared minus 2x minus 35. Since our two numbers must have a product of negative 35 and a sum of 2, the two numbers will have to have different signs. So the factors of negative 35 is negative 1 and 35, so the factor would be 34. So that is not possible. 1 and negative 35 will be negative 34, so that is not also the answer. Negative 5 and 7 will be positive 2, so that is not the answer also. 5 plus negative 7 will be negative 2. There you have the answer. So x squared minus 2x minus 35 is equal to x squared plus 5x minus 7x minus 35. So that will gonna be x plus 5 multiplied by x minus 7. Again, to check your answer, do the FOIL method. Now let's talk about factoring trinomials. Ax squared plus bx plus c. If we turn into the FOIL method, so we're going to have it like this. 3x plus 2x plus 2. So the answer will be 3x squared plus 12x plus 2x plus 8. So bring down the 3x squared, add the 12x plus 2x, so that will be 14x, then bring down the 8. To factor ax squared plus bx plus c into a number 1 multiplied by x plus number 2 and number 3 multiplied by x plus number 4. Note that a is the product of the two first coefficients. C is the product of the two last coefficients, and b is the sum of the product of the outside coefficient and inside coefficient. Note that b is the sum of two products, not just two numbers, as in the last section. Let's go further. For example, factor the polynomial 25x squared plus 20x plus 4. So the possible factors for 25x squared are x and 25x, or 5x and another 5x. Possible factors for 4 are 1 and 4, or 2 and 2. We need to methodologically try each pair of factor until we find a combination that works, or exhaust all of our possible pairs of factor. Keep in mind that because some of our pairs are not identical factors, we may have to exchange some pairs of factors and make two attempts before we can definitely decide a particular pair of factors will not work. We will be looking for a combination that gives the sum of the product of the outside terms and the inside terms equal to 20x. Let's try it now. So the factors of 25x squared should going to be x and 25x, x and 25x, and 5x and 5x. Factors of 4 is 1 and 4, 2 and 2. Resulting binomials will be the following. Product of outside terms will be this. The product of outside terms will be this, and the sum of products will be the following. So, check the resulting factorization using the FOIL method. So do the FOIL method again, and you will have 25x squared plus 20x plus 4. So our final answer when asked to factor 25x squared plus 20x plus 4 will be 5x plus 2 multiplied by 5x plus 2, or 5x plus 2 to the second power. You may pause this video to review how it goes. Another example. Factor the polynomials 21x squared minus 41x plus 10. Possible factors for 21x squared are x and 21x, or 3x and 7x. Since the middle term is negative, possible factors of 10 must be both be negative, negative 1 and negative 10, or negative 2 and negative 5. We need to methodologically try each pair of factors until we find a combination that works, or exhaust all of our possible pairs of factors. We will be looking for a combination that gives the sum of the product of the outside terms and the inside terms of equal to negative 41x. Now here is what happened. You may pause this video and look on what happened or the answer. Again, to check the resulting factorization, use the FOIL method. So our final answer when asked to factor will be 21x squared minus 41x plus 10 will be 3x minus 5 multiplied by 7x minus 2. Factoring by grouping. Factoring polynomials often involves additional technique after initially factoring out the GCF. One technique is factoring by grouping. Example. Factor xy plus y plus 2x plus 2 by grouping. Notice that although 1 is the GCF of all 4 terms of the polynomials, the first 2 terms have a GCF of y and the least 2 terms have a GCF of 2. xy plus y plus 2x plus 2 is equal to x times y plus 1 times y plus 2 times x plus 2 times 1. So the answer would be x plus 1 multiplied by y plus 2. You may pause this video to check the answer. Factoring a 4-term polynomial by grouping. First, arrange the terms so that the first 2 terms have a common factor and the last 2 terms has a common factor. 2. For each pair of terms, use the distributive property to factor out the pair's greatest common factor. 3. If there is now a common binomial factor, factor it out. 4. If there is no common binomial factor in step 3, begin again, rearranging your terms differently. If no rearrangement leads to a common binomial factor, the polynomial cannot be factored. Example, x to the third power plus 4x plus x squared plus 4 is equal to x times x squared plus x times 4 plus 1 times x squared plus 1 times 4. So the answer will be x squared plus 4 multiplied by x plus 1. Again, you may pause this video to check the process. Factoring perfect square. Recall that in our very first example, and we attempted to factor the polynomial 25x squared plus 20x plus 4. The result was 5x plus 2 multiplied to the second power, an example of binomial squared. Any trinomial that factors into a single binomial squared is called a perfect square trinomial. In the last chapter, we learned a shortcut for squaring a binomial. So, if the first and last terms of our polynomial to be factored can be written as expression squared, and the middle term of our polynomial is twice the product of two expressions, then we can use these two previous equations to easily factor the polynomials. So example, 16x squared minus xy plus y squared. Since the first term is 16x squared, can be written in 4x to the second power or squared, and the last term will be y squared is obviously a square also. We can check the middle term by doing this. 8xy minus 2 multiplied by 4x times y. Twice the product of the expression that are squared to get the first and the last term of the polynomials. Therefore, 16x squared minus 8xy plus y squared is equal to 4x minus y squared. Note, you can use FOIL method to verify the factorization for the polynomial is accurate. Difference of two squares. Another shortcut for factoring a trinomial is when we want to factor the difference of two squares. A squared minus b squared is equal to a plus b multiplied by a minus b. A binomial is the difference of two squares if, number 1, both terms are squares, and 2, the sign of the terms are different. 9x squared minus 25, there's a difference, minus. Perfect squares. 9 and 25 are perfect squares. So bring it down, we have 3x plus 5 and 3x minus 5. Learning from home can be difficult, but it's definitely achievable. Thank you for listening. See you next time.